Okay, let's wrap up our notes here on describing distributions with graphs in our introduction to distributions. So we've talked about you want to look for overall patterns. Is it symmetric, skewed left, skewed right? Maybe it's chaotic, but is it symmetric, skewed left, skewed right? Those types of things. Also look for outliers. Are there striking deviations from the overall pattern? Okay? And so you always want to try to describe the shape, if it is symmetric, skewed left, skewed right, and so forth. You also want to describe the center and spread. Those are things we can do quantitatively in the next section. Let's see. So to recap, sometimes distributions are symmetric. You got mirror images. Sometimes they're skewed left, skewed right. Here's some pictures. If you were to draw curves over the histograms, smooth curves, they would look roughly like this. So symmetric. Again, it doesn't have to be bell-shaped, but you have mirror images. This particular bell shape is called a normal distribution. Skewed left, skewed right, you have a long tail on the left or the right, skewed toward the tail. We're going to talk about how it pulls the mean toward the tail in the next section. The last thing, I don't cover this a lot in my elementary stats class, but another type of graph you could make if you're measuring a quantitative variable over time, you can make a time plot. So these are really good if you do have some quantitative variable you're looking at over time. It shows behavior over time, where you basically just make what later we're going to call a scatter plot. You plot your regular XY points, but it's doing a variable where your x-axis, your input variable, is time. So here's your average college tuition and fees over certain years. It'd be very interesting to get the next 20 years to this graph. This one's a very old one that I have that ended at 2000. But you can see there they did separate graphs for public versus private. Both of them increased over time. Private increased a lot more and was always a lot higher over time. So it's a good way to look at trends over time. It's just on one axis you have literally time measured by the years here, and then you're plotting something. In this case, your average tuition and fees. Just one last slide on it. Scales matter when you do graphs. Be careful, don't get tricked by scales. Here's some sort of cancer death rate where I have 4 different pictures, 3 or 4 different pictures. I guess 4 of them. And depending on the story you're trying to tell, you might show people this picture where it's really flat and say, the death rates have been going up over time, but not very fast. It's not very steep. But if you change a different scale, you might say, look, they're skyrocketing over time and it's a lot steeper. So how steep the graph looks in the picture depends on the scale that you pick. So be careful, make sure you pay attention to scales. This was the textbook author's words. A picture's worth 1,000 words, but there's nothing like the hard numbers. Look at scales. Okay, so that concludes chapter 1.